All right, and one other thing that I didn't let you guys know before I started is as soon as I hit go, as people are filtering in here, while their headphones are turning on, they can't necessarily hear what we're saying. So we just kind of sit here for a second while everybody gets their sound equipment up and going. Okay. Oh, good morning, Chris. Nice to see you, and Kevin, colleagues here at City Lights. And I'm probably going to butcher this name. Clement, you've been on several times. Thank you for joining. All right. It's 10:01, so I'm going to start my first slide so we can get going to Levin's presentation. Welcome to the first webinar in May. We are excited to have Levin Nock from DesignLights Consortium, and a topic that has been on my mind since we've made the transition from lighting design labs sort of exclusively and controls to broader technologies, including HVAC, how to unlock HVAC energy savings and save money by integrating lighting controls. Um, and 6 degrees of Kevin Bacon or whatever. My manager, Arena, worked for DesignLights Consortium, so kind of a little connection there. And just like always, if I can find my controls here, we're going to do a Slido poll real quick here at the beginning, just so we know a little bit about who's on the call. So you can get out a device and scan the QR code, or pop open another browser tab next to the 100 that you already have, and go to slido.com. You'll type in that 7032895 number to get into Slido. And then our particular poll, you'll hit the WMZDQQ to get access to the poll. I'm going to leave that up there for just another second, but I have this info on the next slides as well. So when I switch, don't worry. Okay. Let's see if it will advance here. Here we are. If you haven't taken a webinar with us before, you're all on mute for the duration, but you have the ability to ask questions through the questions tab window. Look for the question mark inside the little dialogue, excuse me, cartoon box. Click that and you'll be able to ask us questions anytime. They'll come to me so that Levin can focus on his presentation. If they're kind of urgent, I'll ask them right away. Otherwise, we're going to save them for sort of Q&A breaks. You can get into the chat, but you can't use it. Don't try to type anything into there. This webinar is being recorded, so you can go back and find spots where you maybe need to listen again. You can hand it out for Mother's Day if you want. It'll be on our website within about a week. And there's a survey as soon as we close out. We would really appreciate you taking it. Thank you to everybody who's taken it. I think we've got a pretty good, excuse me, I need something to sip on. Uptake on that survey. It really does help us out. All right. And I am going to tell you just a little bit about the Lighting Design Lab if you don't know. We've been a part of City Light for decades. Those pictures there are what our Soto building used to be. We used to have our own little building. You could see different types of lighting. Oh, excuse me, hang on. If it's not the technology, it's the human error. And the lab was focused primarily on lighting, but now we've expanded and we're being rebranded. So if you have any name ideas for what we could be called, type those into the questions. We would like to hear your creative answers. And here's your turn. Who are you? You're going to have to type in what your job title is in this Slido poll. So, or what you do for work. Are you an architect? Are you an energy advisor? Do you work for government? All right, thank you for participating. Oh, good. Yes, good, good. And perfect. Okay, I'm going to give one more second because it takes a minute to type if you're typing a whole thing like energy management analyst. Perfect. All right, and going to go to the next question, which is easier. Just click. Do you work Seattle area? Are you a little bit outside Seattle, or are you not even in the state? Great. Nice. All right. Then I've got, I think, one more slide to tell you about our upcoming courses. We've got one more codes class with Dwayne from SDCI and talking alterations for both Washington and Seattle code. Really excited to have a passive house focused webinar, but for all buildings. It's not just passive house anymore. Um, and with, oh my gosh, I just forgot his name and my notes aren't up, from Methune, right, Robert? Yeah. So that'll be really good. And then we do have a training on on City Lights' new distributed interconnection handbook. We don't know when that's going to happen yet, sometime early summer. And Seattle City Light has a trade ally program now. We just started. We have an opportunity once a month for you to get one-on-one FaceTime with the people that do the incentive programs, like my colleague Jim, who's going to come on towards the end and talk about some lighting HVAC incentives that we might be able to do customized for some of your projects. Alrighty, and with that, let me introduce Levin Nock from DesignLights Consortium, um, here to give us all the information on how to integrate those two technologies to save money. And then we'll have Jim come and talk about how City Light specifically might be able to help you out with that. All right, Levin, you ready?
I think I'm ready.
Excellent. Go ahead.
Okay. Um, Thanks. So, yes, my name is Levin Nock. I work in the Network Lighting Controls program at the Design Lights Consortium, or DLC, as a senior technical manager. I've lived in the Pacific Northwest for over 30 years now. And before joining DLC, I worked for 5 years as a contractor in the Bonneville Power Efficiency Program, working on LED lighting and lighting controls. So now I'm working out of Boston, but living in Olympia, Washington. And the DLC, as you probably know, is a nonprofit that keeps lists of high quality, energy efficient lighting products um, for non residential buildings. And we do this in collaboration with utility energy efficiency programs, lighting manufacturers, and other stakeholders. Since 2016, I've helped manage our list of network lighting control systems that are eligible for energy efficiency rebates and incentives across many parts of the US and Canada. NEA is a member of the DLC, and so all energy efficiency programs in the Pacific Northwest are members of the DLC through their membership with NEA. In the agenda, first I'll introduce some context about what makes lighting HVAC integration relevant today. Then we'll explore the new integration toolkit and its value for integration projects. I'll describe recent developments in standardized digital protocols for network lighting controls that are making some network lighting control systems easier to integrate with other building systems such as HVAC. And as I mentioned and so please enter any questions as we go along, and Bonnie will bring up a few key ones between sections, and then we can dive into the main ones at the end. Uh, so now I'll continue with the introduction. Let's see. For the past decade, LED lighting retrofits in commercial buildings have delivered affordable and reliable energy savings for electric utilities and for building owners. But now, with efficient LEDs already installed in many buildings, new sources of energy savings are needed. Network lighting controls, or NLC, could help, but they often seem expensive compared to the relatively small amount of energy they save when the only load they control is LED lights. Still, when network lighting controls do manage to make it past value engineering and get installed on a project, they provide powered, networked occupancy sensors everywhere throughout a space. In suitable buildings, signals from those occupancy sensors can inform the HVAC controls to relax the temperature set points by a few degrees in all unoccupied areas. Some buildings can also reduce the ventilation rate for additional energy savings. As you probably know, this is called occupied standby mode. It relies on occupancy sensors, but very few HVAC systems include their own integrated occupancy sensors. If you want to add occupancy sensors to an existing building, then a lighting retrofit project offers a great opportunity to install light fixtures that have occupancy sensors already built in and networked and powered by the same circuit that powers the lights. Today's commercial buildings use more than half of their energy for HVAC and about 10% for lighting. The total combined savings from new LED lights with network lighting controls integrated with HVAC for occupied standby mode can be over 20% of the whole building energy load. Substantial energy savings like that from NLC HVAC integration can be your key to helping building owners unlock rebates, incentives, and lower energy bills by taking a step beyond common practice. Energy savings from systems integration can be attractive to building owners, especially for people with buildings larger than 50,000 square feet that already have a building automation system and may even be subject to building energy performance standards, like the ones coming soon for Washington and then the ones coming in a few years for Seattle in particular. Occupied standby mode is also feasible in some smaller buildings, usually with old-fashioned analog dry contact technology. But thermostats are being introduced now with wireless Wi-Fi and even Bluetooth connections to support plug-and-play digital versions of occupied standby mode in smaller commercial buildings without full-blown building automation systems. Building automation to coordinate different building systems is the wave of the future. Integrating lighting controls with HVAC controls is a good place to get familiar with building automation to apply later across more building systems. Those are some of the reasons why lighting HVAC integration is worth pursuing. However, it rarely happens today. So the DLC has been working on ways to help it happen more often. Last fall, the DLC convened a summit to explore the future of network lighting controls. We heard that very few building owners and facility managers actually request integration projects. What they do ask for is positive outcomes, energy efficiency, and building systems that all work well smoothly together. Lighting HVAC integration based on a lighting retrofit project that includes integrated networked occupancy sensors as part of the retrofit project is a great way to accomplish those positive outcomes, energy efficiency, and building systems that work together smoothly. Before I show you the new integration toolkit, I need to take a minute for a few definitions. The term network lighting control can mean different things to different people. For the DLC, it means a combination of sensors, network interfaces, and controllers that affect lighting changes in luminaires, retrofit kits, or lamps. These devices may communicate with each other using a wired protocol such as DALI 2 or a wireless protocol such as Bluetooth NLC. When sensors from occupancy control and daylight harvesting are on board every fixture, that's called luminaire level lighting control or LLLC. that is good for spaces of all sizes and especially good for smaller buildings. I'm treating LLLC as one kind of network lighting control or subset. Some network lighting control systems are connected to the internet, while some are not. Others have an occasional internet connection through an operator's mobile device. So now we'll pause for questions and then explore the new toolkit.
I don't have any questions on that, but one suggestion for a new lab name. So thank you, Cameron, for for that. But no questions so far. I think it's pretty clear.
Okay, thanks. So now the new integration toolkit. The toolkit can be downloaded for free at the DesignLights.org webpage for NLC HVAC integration. You can find the webpage using this QR code that will show later during the questions, and I will also post it in the questions pane later in the session. And I also want to apologize profusely. I just tried to download this before this webinar this morning, and the website was broken. So I encourage you to download the toolkit, and I also encourage you to wait maybe a day or two until the website gets back up. So if it doesn't work, please just try it again in another day or two, and I'm hoping it'll get fixed soon. Very sorry about that. The toolkit, when you get it downloaded, will help you choose appropriate projects for integration that are likely to save energy at a reasonable price. They will help everyone on an integration project work together more effectively, and they will help your team create successful projects that save energy by providing lighting, thermal comfort, and ventilation only when and where they are needed. My goal in this presentation is to introduce the toolkit to you so you'll know what's in it in case you ever want to use it. And second, to ask for your feedback in the Q&A session later and also anytime afterwards if you want to share your experience using the toolkit or you see ways that DLC could improve future editions. The toolkit contains 5 different files bundled up in a zip file. First is the handbook, a concise reference manual. Next is the decision tree, a guide to help you choose appropriate projects for lighting HVAC controls integration, and also avoid projects where success is unlikely. Next, there's a spreadsheet list of case studies of 18 integration projects, so you can read about projects like yours, including lessons learned. Files 4 and 5 document an example project and can be edited to apply to your own project. The responsibility matrix describes major tasks and participants, showing who is responsible for what. And the project template is an example construction integration specification aligned with CSI Division 25 on integrated automation. Next, we'll look at some of these documents in more detail. The handbook is a concise reference manual with the different sections shown in this table of contents. The definitions include 5 pages of essential terminology, and standards listed in the reference at the end define many additional terms that might be new to some readers. The goal is to help everyone on an integration project understand what the other people in the project are doing. For instance, people experienced in lighting controls will already know most of what's in the NLC section. But if they read a few pages about building automation and management systems, they might be able to collaborate better with folks working on those systems, and vice versa. The best practices section has some general tips for everybody, and the references section includes standardized recommended practice, such as exactly how to write a good sequence of operations in the world of lighting and also in the worlds of HVAC and building automation. The decision tree diagram has 7 topics to consider when deciding whether to pursue NLC HVAC integration on a particular project. This one-page diagram is sufficient by itself to eliminate some projects from further consideration. If a project might have potential at first glance and you want to consider it more carefully, Then each topic in the diagram has a corresponding page in the PDF file with a number and color for that topic. You can click on a topic number in the diagram to navigate to the page about that particular topic for more details. Each of the seven topics in one of the seven topics involves how the lighting zones are laid out in relation to the HVAC zones. Here's an example of a floor plan with different lighting zones in different colors. And then when we overlay the boundaries of the HVAC zones that are shown in dotted lines, then you can see that most of the boundaries line up pretty well. Each HVAC zone is comprised of a group of multiple lighting zones, which makes this building a good candidate for integration. If some of those HVAC boundaries had crossed through the middle of a single lighting zone, that would make integration more difficult and possible less successful, depending on exactly how you handle the different occupancy sensors. Next is a list of case studies of NLC HVAC integration projects. This zoomed out view of all the data in the Excel file. Each row describes one of 18 case studies, and each column addresses one topic. The data can be easily filtered based on any of the topic headings. Most of the projects are retrofits, but a few are new construction or major renovation. Here's a list of all 22 column headings. You don't need to read them all here because I'll go through them in 3 different groups. The first 9 topics are all pretty short, as shown here, such as building type, location, square footage, building characteristics, and which systems are integrated. The next 4 columns have more extensive text with a summary of each project, a description of the project objectives that drove the decision for integration, a list of lessons learned from the project, and an overview of the control strategies that were used in each project. And then there are columns about the HVAC system type and schedule, energy saved, payback, incentives, date, and the source website where you can find the full original published case study. You can see that some of the cells are empty because some case studies did not address every topic. The 18 projects include these 7 different types of building. So you can see how some of the control strategies and the integration objectives varied by building type. We aim to make the list larger as we find more case studies that are suitable. There are also 2 templates to help you manage who's doing what in an integration project. A responsibility matrix in Excel linking people with tasks, and a CSI Division 25 contract excerpt for integrated automation to specify what needs to be done. The templates can help you plan ahead, so each part has clearly defined responsibilities to avoid finger pointing later. That concludes our tour of the main features of the new DLC NLC HVAC Controls Integration Toolkit. Please try it out, and if you do try it out, I would love to hear about your experience with it in terms of what works and what could be improved. Any questions about that section?
We don't have any questions yet. I'll just say a little reminder, if you do at any point have a question, click that little question mark on your toolbar and it will get on over to us.
Okay. Thanks. So now we'll explore some recently introduced digital standards that are making integration projects more doable more easily than they used to be. Recently developed open digital protocols are supported by rigorous certification programs that support reliable, predictable performance, even when you mix and match components from multiple vendors. For integration projects, you can get reliable digital sensor data out of these systems in a standardized format. I'll update you on 2 of those open certified protocols and how to find NLC systems that use them on the DLC list. But first, I want to show you why standardized, reliable performance is such a big deal. In the past, lighting controls have depended on control protocols that were difficult to maintain over time and difficult for other building systems to work with. Proprietary protocols only work with one vendor's products, and analog protocols are unreliable. For example, in the analog 0 to 10 volt protocol, if it was reliable, then this chart of analog dimming control input signals on the x-axis versus the output power from 24 different streetlight drivers on the y-axis would show all of those different colored lines as one single identical line. The DALI Alliance promotes DALI digitally addressable lighting interface for digital communication between lighting control devices. DALI-based wired lighting control systems are common in Europe, and recent developments are gaining popularity in North America. In 2017, the DALI 2 protocol was published for wired networks between luminaires and other devices. DALI 2 requires certification testing to support interoperability between certified products and defines protocols to manage data from sensors in a standardized way. In 2019, the D4I protocol for communication between components within a single luminaire was adopted in North America as the ANSI C137.4 standard. LED drivers that support ANSI C137.4 communicate digitally with sensors and controllers and use North American power supply voltages. This yields standardized digital data that other building systems can interface with. And since 2021, the DALI Plus protocol brings DALI open standardization to wireless networks between luminaires. The other big thing happening in digital lighting control standards is Bluetooth. In 2010, the Bluetooth Low Energy Standard addressed the radio layer of a network lighting control system, where devices transmit wireless data over radio frequencies. But for the communication and device layers, each different product used a different proprietary solution. In 2017, Bluetooth Mesh addressed part of that problem by standardizing the communication layer, but the device layer remained proprietary. Only since 2023 has a full stack standardized Bluetooth wireless mesh solution become available. It's called Bluetooth NLC, and it supports multi-vendor solutions for network lighting controls, so you can now buy a wireless lighting control system with no worries that the vendor might go bankrupt and leave your equipment stranded without service support. In large buildings with a building automation system, a Bluetooth NLC lighting control system can communicate with the building automation system through a BACnet gateway. For smaller spaces with no building automation system, a new Bluetooth NLC component profile is coming soon to let Bluetooth-enabled thermostats communicate directly in a standardized way with the occupancy sensors of a network lighting control system. That will support Lighting-HVAC integration through Bluetooth NLC, even in smaller buildings with no building automation system. To find products that use standardized, certified digital protocols such as these, you can check out the DLC's list of over 90 different network lighting control systems. You can filter the list for products with various capabilities, including those shown here that are especially relevant to Lighting-HVAC integration. On the DesignLights.org website, once you're logged in with a free account, you can choose Find Products and then NLC QPL. To see the whole list of 90 network lighting control systems, you can use the filters on the left to narrow down the selection. Or to get a spreadsheet of all the detailed data, you can make a list of all the systems that you're interested in, add the results to your list, and then you can download all the data from your product list to an Excel spreadsheet with a row for each NLC system on your list and a group of columns for each of these 22 capabilities that DLC collects data on, for a total of more than 120 columns of information about each system. And let me go through that list a little more. So as you can see, there's a whole section on networking um, in terms of what really matters for integration. There's um, well, scheduling, remote diagnostics, um, luminaire level lighting controls is very important in the Pacific Northwest because a lot of the incentives are geared to luminaire level lighting control. And then we have a whole section on external systems integration and one on cybersecurity, where you can find several different parameters that are important for choosing a network lighting control system that'll fit well into your integration project. And just to recap, in conclusion, DLC has published a toolkit collection of 5 documents that's freely available for you to use on projects to integrate network lighting controls with HVAC controls. These documents point to several additional resources, one of which is the DLC list of network lighting control systems, where you can see which systems support which popular digital standards to make your integration projects run more smoothly because they manage sensor data with open digital standards. The toolkit will help you choose appropriate projects, will help everyone on a project work together more effectively, and will help your team create successful integration projects that save energy. Doing a lighting retrofit project that includes lighting HVAC integration will help you achieve positive outcomes while your building saves energy and has different building systems that work together smoothly. This is all those things I just said are especially true now for large buildings and campuses that have a building automation system where custom projects for efficiency incentives make sense to be tailor-made for each project. It's also becoming easier and more feasible in smaller buildings. And utilities, progressive utilities such as Seattle City Light, are exploring possible ways to promote incentive programs that will support integration projects more fully in smaller buildings. And so now that was all for me. And the next section is more details about the different incentives that are available for integration projects of various sizes.
Yep, that is right. Thank you, Levin. What a great tool. I am particularly interested in getting in there and seeing what the sample projects are. And let me come back to my slides real quick. And my colleague Jim Lowen's going to come on and talk to you about city light incentives related to what Levin was talking about. And there we go. Jim, are you there with me?
I'm right here.
Excellent. All right, here's your title slide. Take it away.
Okay, great. I'm with Seattle City Light. We provide electric service throughout the Seattle, primarily the Seattle area, but also including some areas north, such as Shoreline, and some areas, excuse me, south, such as Burien and parts of Tukwila, and even into Renton a little bit. We've done a lot of projects over the years. We haven't seen much in the way yet as far as combining lighting with HVAC, but we're starting to see more and more of that. I think especially too as the Seattle Energy Code requires a certain amount of integration. Uh, let's go ahead and go to the next slide there, Katie. So we have incentives directly for lighting. A lot of smaller projects, we have what's called our Lighting to Go program, where discounts are offered for the bits and pieces, if you will, of lamps and fixtures that contractors get when they purchase the equipment from participating distributors. For bigger projects where customers are doing either major retrofits or maybe floor by floor, we have specific incentives for component retrofit kits, retrofit fixtures, controls upgrades, and then if you're getting, like Levin was describing, NLC and LLC type fixtures, then we have additional savings, not just for kilowatt hours energy reduction, but also $75 or $50 per fixture, which can be pretty substantial. Go ahead to the next slide there, Katie. So here's a quick summary of one project where they had both fixture upgrades and controls, and you see under section 6 there to the right that the bonus incentive for the improved controls was $17,000, but yet just for the fixture efficiency for kilowatt hour savings was $6,000. So there's quite a bit of add-on if a customer chooses to get fixtures with the integrated controls. And again, these are occupancy sensors and daylight sensors that are built into the new fixtures. In this case, we covered 47%. Typically, we cap our incentive at 70%, so that can be a pretty good bonus overall for a project to make it much more cost effective. Go ahead and go to the next slide, Katie. So HVAC, there's an awful lot of HVAC types of systems out there. Here's just an example of what we focus on. Different types of control upgrades, certainly including occupancy sensors, heat pumps if you're installing new systems. Commercial and multifamily is typically where we see those. Cooling, we've got different kinds of projects for data centers and large commercial buildings with cooling towers and chillers. And then ventilation, we see projects with DOAS and economizers, and certainly a lot of variable speed drives being added on. And in some cases, demand control ventilation, where customers are adding the CO2 monitors. Go ahead and go to the next slide. So we have one type of conservation measure which looks at control upgrades. So this is kind of a whole building kind of analysis where we look at the property and the details of the project, what the customer is going to be doing. We look at the cost and the estimated savings, and we pay approximately half the estimated incentive when the project is installed, and then we monitor the project, and at the end of the first year, we do the true-up savings, if you will, and pay the balance of the incentive calculated based on actual performance. This is one type of control project. We also have an option where customers might be looking at whole building commissioning of systems, or they're just modifying a smaller scope project, which may not qualify for this type of a regression analysis, but we've got a lot of flexibility to look at things in a different way. Go ahead and go to the next slide. So we did a project a few years ago where the university upgraded all the VAV terminal boxes on, I think, 5 air handling systems, over 183,000 square feet. And there were a total of 220 VAV boxes affected. Some of those boxes, they replaced the motors with ECM style. They converted some boxes to cooling only. And then all the boxes, they reduced the primary air by about 10 to 15% without any impact on air quality. Based on the project cost and the energy savings, in today's incentive rate, which is going to be going up shortly to 36 cents, we would have paid $299,000 towards this project. There was also some payment from Puget Sound Energy because there was gas savings. So where projects have the dual fuel savings, we coordinate with them. Overall, though, we won't pay more than 70% cap of incentives to project cost, but this one was a real good project for them. Looking at possible tie-ins, and this is what Levin was referring to, we could do things like reduce the ECM motor speed, and then we could increase the deadband so that instead of maintaining 71 degrees heating, we could drop that down to 69, or raise the cooling setting from, say, 73 to 75, and create a standby capability. Another thing we could do is if the system is scheduled to operate, say, from 8 in the morning till maybe 8 at night, because there's a lot of classrooms, well, because of an occupancy sensor tie-in, we could then cause individual zones then to go either into the setback mode or into a complete off mode, depending on what we wanted to accomplish. That way we can essentially provide a time schedule of sorts that's flexible for each zone, as opposed to waiting for the air handler to shut down maybe at 10 o'clock at night. Go ahead and go to the next slide. So we've got different ways you can contact us and find out about our programs. We have the email address there. Our energy advisors are standing by, waiting to hear from you, or you can call our phone number, which is active, all the time. We've also provided a link to our website that talks about our different programs and options. We do have a number of items there that relate to lighting, including excuse me, a detailed description ourselves of network lighting controls and luminaire level lighting controls. So there's a lot of ways you can get information from us and about our programs. I think that's probably the last of my slides. Is there another one,
It
Katie?
is. Nope,
Okay. So
this is our final slide. So we are officially in Q&A. Thank you, Jim, for that explanation. We've got a few questions.
sure.
Levin, if you want to come back on, it'll be, for all of us. Um, so for Levin, what are some cybersecurity concerns of these kinds of lighting controls?
Well, so all of the lighting controls on the DLC qualified list have a cybersecurity certification. And depending on the type of building that the project is in, there may be various levels of interest in maintaining cybersecurity rigor. So you can choose systems that have been certified in several different ways. I guess of course, the concern is that the weakest link in a whole building uh, may provide access to hackers that could get in to other systems. There is some concern about someone taking over the lights. There's even more concern about someone getting into the building through the lights and getting into another, either a building system or even into the operations system. But there are uh, lots of people who are very good at cybersecurity. It's just important to work with your IT department and have a strategy for dealing with cybersecurity and treating it as an important part of the design.
I should kind of interject here that there's been similar concerns for HVAC control systems for probably 15 years. When they were first being integrated, customers were worried about, okay, I've got this computer and it's linked to some network. How am I protected from people coming in and turning systems on and off and playing havoc on it, or are they going to get into my personnel files somehow through the HVAC system? So it is something that everybody wants to be aware of.
Yeah, there's different strategies. Some buildings put everything on a single Ethernet, but then they also segment off parts of it where there's firewalls between different building systems. Other systems really have two networks, where there's one network for the operational tech and a separate network for the building tech. So there's different ways to do it. It just depends on doing something to make sure you're covered well for cybersecurity.
Yeah,
Right.
Levin, you had a chart, excuse me, Levin, you had a chart that showed kind of the lighting being integrated to the building. Another application just decided the security system. So if occupancy was triggered and people are in a space that they're not supposed to be in, then security, whoever's monitoring, would pick that up and go check it out if nothing else.
Yes, and that can also help when you've got the lights on occupancy sensors, as well as showing up with a message, hey, nobody's supposed to be there. Like the whoever is there, the night guard or whatever, can see, hey, that light over there should not be on.
Yep. All right. And Jim, you might know the answer to this. I think I do, but I'll ask you just in case. Does the Seattle Commercial Energy Code require lighting control integration with HVAC? I don't think it goes that far.
No, the
Yeah,
only application I've seen there's one where they're looking at like the access controls to hotel rooms, that kind of thing, where you put your room
right.
card and the device and your HVAC and lighting is activated together. Uh, there's another small application. I don't remember where it was at the moment, but in general, no, I don't think the Seattle Energy Code implements any requirement at the moment. 3 years from now, maybe it will, but right now it doesn't. You do have to
Yeah.
have pretty good sophisticated controls for the lighting and for the HVAC, but no direct relation. Even though you can, utilize it, that's not discouraged. It's just not specifically required.
All right. And then, um, oh, Arthur was trying to access the toolkit, Levin, and said Chrome didn't seem to allow him to access it. Do you know if that's maybe just a result of the website not working or?
I'm using Chrome too, and it didn't work for me either.
Okay.
So
All
it
right.
it
So
should work soon, just not
Arthur,
at the
stay
moment.
tuned.
I'm very sorry.
That's okay. I mean, what, of course it would go down on the day where you're
Yeah,
giving this presentation.
yeah.
Okay, I don't have any other questions right now. I will give another couple minutes for people to get their thoughts in if they have them.
Oh,
Uh,
I did put the
oh, good.
website in the questions, but can everybody see that, or could you put that somewhere where everyone could
Let
see
me
it?
put it into the chat. So everybody, you should have a little notification on your chat button that says there's a new chat or something. So if you click that open, you'll get the link from Levin. And all of these links will be active on the PDF that I post on our website with the recording. So you'll be able to click on them. You obviously can't click on them now, but um, uh, so give me a week to get that up on our website and you'll have the recording, you'll have a copy of the slide deck with all of the links active. And let me give one more check to the questions. Nope. All right. Then we will end a little bit early. Thank you both for coming on. Thank you for some people are clapping for us. I don't know if you can see the little, the little clappies. Nobody mentioned my haircut, but that's all right. Anyway, I will see a lot of y'all back with Dwayne and Levin. Thank you so much. And I think you'll probably be at EFX in Portland.
I will be at
Yep,
Efficiency
I will be
Exchange,
there
and I
too. So,
I just noticed that Armando is on this call, and I need to give a shout out to
oh,
Armando
great.
because
Yes.
a few years ago he instigated a new standard, which makes it really easy for utilities to get a report for how a network lighting control system is configured. So this will make everyone's life easier in terms of applying for incentive and
Yep.
getting an incentive. And I want to say that just like a week ago, that standard was published. So thank you, Armando, and it exists now.
Yep. That's been a long time coming. All right.
Yeah.
Thank you both. I'm going to click off. Please take the survey if you do not mind and have some time. Thanks, everyone.
Great. Thanks, Levin. Appreciate it.
Oh, thanks for having me. Yes. I couldn't see people. How many people were there?
Oh,